Okay, today's lesson is applications of rational functions, and we're going to review for the quiz that you have on Thursday. Okay, the first problem here talks about a car has a front-end collision. The objects in the car, including the passengers, keep moving forward until the impact occurs. Seatbelts and airbags limit how far you are jolted forward, then you are thrown back. The formula for the velocity you're thrown back is, and pay attention, it's this V right there. I missed that the first time I read it. Mass 1 minus mass 2 over mass 1 plus mass 2 times the initial velocity, or how fast you're going when the collision happened. Okay, so you want to graph it. They're going to give us 10 for mass 1 and a velocity of 5. So my function becomes 10 minus m over 10 plus m times 5. And I rewrote that. I'm going to rewrite it down here. Hang on. To 50 minus 5m over 10 plus m. All right, they want you to graph it. So your vertical asymptote is what makes the bottom 0. In this case, it's negative 10. And your horizontal asymptote, they have the same degree because m's your variable. They're both 1s, so it's at negative 5. Okay, and then I'm going to admit I put it in my calculator and looked at the graph, and my graph comes down like this. Sorry, I know it goes through here because when you plug in 0, you get 50. So this is 5. All right. Okay. Using the values from part A, find the velocity when you're thrown back if m2 is 20 milligrams. So you're running into something that's twice as big as you are. Okay, so 10 minus 20 over 10 plus 20 times 5 gave me negative 1.667 meters per second. What's the negative mean? It means you're going backwards. Okay, positive velocity is going this way, negative velocity is going that way. All right, let's talk about these asymptotes also in a reasonable domain. My domain, negative 10 to infinity, but truthfully, does that make sense? Can you have negative weight? No. So probably from here forward. And that makes sense because if your mass is, okay, minus a negative 10 is 20 over 0, so it doesn't make sense. If you hit something smaller, you could. I guess that's what that means. You're 10 milligrams and they're negative 9. That doesn't make sense. Your mass has to be 0. So let's cross that out and make 0. All right. What's the horizontal asymptote? It tells you it's your end behavior. Remember, your graph is approaching negative 5. So it's telling you, generally speaking, the biggest number you're going to be thrown back at is negative 5 meters per second. All right? All right. Write a function that has, all right. Write a function that has a vertical asymptote at 2, a hole at 4, and an intercept of 3, and a horizontal asymptote of 5. Leave in factored form. A vertical asymptote at 2. Okay. So the bottom has to be an x minus 2. A hole at 4 means they both have to have the same thing. So you have x minus 4 and an x minus 4. If you want a horizontal asymptote at 5, they have to have the same degree and a factor of 5 at the top. So it has to be a 5x. It might be 5x minus something plus something. It doesn't matter. All right? Has a vertical asymptote at 5 and a slant asymptote at x plus 8. So the bottom has to be x minus 5. If you want a slant at x plus 8, it has to be an x minus 5 times x plus 8, because when you multiply that, you get x squared plus 3x minus 40. Because if I divide the bottom into the top, okay, if I put that up here, I divide the bottom into the top, it's going to go in evenly, and I'm going to have a hole. So what I need to do is change this value so that it doesn't go in evenly, and I'm going to have a remainder, and then I'll have a slant asymptote. Okay, got that? Pay attention. This is what you want. You have this in the bottom. When you multiply them, you get a quadratic. But if it divides evenly, you're going to have a hole. So we don't want a hole, so you just change this to a 7 instead. Or change something so that this is different. So when you divide, it still goes in 8. Okay? Let's check it. I put in a 5. I have 3. No, I have 1 plus 3 minus 30. I bring down the 1, you get 5. You add it, you get 8. Bingo. That's 40, and you get a remainder of 10. Okay? I added a few more on here because I didn't realize that was there. So let's do one more. Oh, I forgot to change it. Is it the same? Yep, that's the same. All right. We want to do these. Find the following rational functions. Find all asymptotes, whole zeros, domain, and behavior, and sketch the graph. Okay, so the top one, it factors into 3 times 5x plus 1. And the bottom, oh man, that's a mess. Let's clean that up. And the bottom is 5 over x plus 2. So no holes. Okay. What makes the bottom 0? Okay, so that's your asymptote, -2. And that's the vertical asymptote. And also your domain goes from -infinity to -2 and -2 to infinity. The horizontal, they're the same degree, top divided by bottom, so you get y equals 3. The zeros are when the top equals 0, so 15x plus 3 equals 0. So x equals -3 over 15, or -1/5. And if y equals 0, or x equals 0, then y is equal to 3/10. Alrighty. And behavior, x is going to infinity, y is going to approach 3. That's your horizontal asymptote. X is going to -infinity. Y goes to 3. Sketch. Oh, that's a bad line. Let's fix that. Oop, boop, 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 boop. Okay. Okay. -2. 3. Oh, come on. Nope. Lordy. We've got to do vertical at -2. Do. And horizontals at 3. And then remember, when you graph, you just have to pick some points. What happens when you plug in 0? We said the intercept is at 3/10, so that's down here. And your x-intercept is a 1/5. It's here. That doesn't make sense. Oh, it's -1/5, so it's here. So this is going like that. What's it doing on the other side of that asymptote? If you plug in -3, you get -45 plus 3, so that's negative over a positive. No, negative over negative is positive, so it's up here. Okay? A little complicated. All righty, I didn't leave enough room to work. I can see that. All right, first thing we're going to do is factor. So you get x minus 5 and x plus 1, x plus 1. Oop. These guys cross out, so I have a hole at -1, and you plug -1 in there and get -6. No asymptotes, because you have a line with a hole in it. Okay, so I'm going to graph it. My line is x minus 5 with a slope of 1, and the hole at -1, 6. Okay, your domain negative infinity to negative 1, negative 1 to infinity. End behavior, x goes to infinity, y goes to infinity, x goes to negative infinity, y goes to negative infinity. All right? Next. First thing you always do is factor. So you pull this out and you get 2 over x minus 2. What happens to the bottom? You have 2x. I bet you one of them is minus 4. Does that work? You get, oh, this should be an x. Sorry. So you get 2x squared minus 4x plus 2. Yep. So let's leave the top the way it was. 2x minus 4. You always check that. Okay? Now what happens? Oop. These guys cross out. It's not a line this time, though. It's a rational function with a hole. Okay, so your hole is at, what, 2? When you plug in 2, you get 1/3. Asymptotes. You have x equals negative 1 and y equals, it's now bottom heavy, so it's 0. End behavior, x goes to infinity, y goes to 0, x goes negative, y goes to 0. Graph, put in your asymptotes, negative 1, 0, and then you got a graph, oh, we're at 2 and then 1/3, so that's here, so you know the rest of it's got to be up here. What about this side? If I plug in negative 2, I get negative 1/3, so it's down here. Done. Deal. Okay. We got a factor again. Let's see. 3x and x. Oh, 5 and a 1. Oh, doesn't look like it factors. So I guess we'll get rid of that. I know I have an asymptote. Oop. Asymptote. Yep. X equals negative 1. It's top heavy, so y is equal to, oh, it's by more than 1, I got to divide. So I put negative 1 in, 3, 4, negative 5, bring down the 3, 1, negative 6, that's the remainder, we ignore it. So this is 3x plus 1 is a slant. So I'm over here at negative 1 is my asymptote. And this one goes through 1, the slope of 3. X is going to infinity. Oh, infinity. Y goes to infinity. X is going to negative infinity. Y goes to negative infinity. And then you need to graph it. So I'm going to cheat. It's not cheating. It's using my tools I have, and I have, oh, I think I just did it. Squared plus 4x minus 5, x plus 1. And I graph it, and it's my graph is doing this. Okay, you can use your calculator. You gotta still have to be able to answer the questions. Okay. All right. Last problem here. It's top heavy by 2. I know it's x equals negative 1 again. I have to divide. This time you have, let's see, negative 1, 2, 1, negative 3, 7, 2, negative 2, it's negative 1, that's 1, negative 2. 2, that's 9. Don't need that. So y is equal to x squared minus, nope, 2x squared. Hang on. These are the coefficients, remember? 2x squared minus x minus 2. My graph, asymptotes. My parabola is doing this. This one's kind of interesting. I graphed this one too. And this one's over here like this. This one's in here doing this. It's following your asymptotes. So as x goes to infinity, y goes to infinity, and x goes to negative infinity, y still going to infinity. It keeps going up here. All right, good problem. What's the domain? Ooh, it goes from negative infinity to negative 1, and negative 1 to infinity. We did our end behavior. We didn't do our domain here. You leave out negative 1, okay? Here, your domain, you have to leave out the whole and the vertical. So this one is negative infinity to negative 1, negative 1 to 2, and 2 to infinity. Okay, make sure you practice all those. There's a bunch of those in the worksheet. All right, one more thing we got to talk about, transformations. There's a worksheet out there on it. I left it posted. I didn't discuss it. You need to look at it and go over it. This is a real easy way to do it, though. If I have a parent function, 1 over x, that's my rational function, and I want it to go left 3 and up 2. Left 3 and up 2. The thing is I want to change that so they have a common denominator. So I'm going to multiply this by x plus 3 and x plus 3. I get 1 plus 2x plus 6 over x plus 3. And when you combine the 1 and 6, you end up with 2x plus 7 over x plus 3. So you need to know that. Start with the parent, shift it left, right, up 2. Because remember, left and right is attached to the x. Okay, well, what happens if they gave you the equation first and they wanted you to put it in to find the transformations? So this time they gave you this over x minus 2, and they want you to find the transformations. Well, you divide. You go 2, you do 3 and 1. You bring down the 3. You get 6. 6 and 1 is 7. So remember that what's left over can you do that? No. Let me do it again. Ooh. What did I do? Oh, no, that was right. That was right. Sorry, that was right. This is okay. So you end up with 3 plus 7 over the remainder. So now it went up 3 and over 2 to the right. Okay, let's do another one of those because I confused you. 4x minus 5 over 2x plus 1. You go ahead and divide because I put a 2 in front of it. Dang it. 4x minus 5. You multiply by 2 and you get 4x plus 2, and you subtract, get negative 7. All right. Ooh, so I have f of x equals negative 7 over 2x plus 1 plus 2. You have a negative flipped it over. This is a vertical stretch, a horizontal compression, a shift by a half, and up 1. Ooh, I'm not going to do one that complicated on the test, okay? But you can do that. If it's in this format, divide, it gets you into the transformation form. If it's in transformation form, then you get common denominators and add them together. Practice that stuff.